Okay, so we're going to go for linear equations overview. So when we go to graph things, when we write equations, equals mx plus b. Is this a familiar equation to you at all? Yeah? Okay. So the m value here talks about slope of something. And the b value talks about, hi buddy, the y-intercept.
After that, can I do one of those?
Yeah, okay, I'm recording now. Go close the door, buddy. So this is a graph. What's a rough graph? Of something that looks like this. A relationship is a straight line. So that's what linear refers to. Anything that's straight line relationship. We're going to talk about other ones eventually. Quadratics. Quadratics are a little different. They have like a U shape to them. Cubic functions, they got like this S shape to them. So there's lots of other ones we're going to go through, but we're just going to focus on the linear ones right now. So it's just straight lines. And slope just deals with, you'll start to call it rate of change, but it's essentially like it's like the hypotenuse of a triangle. You can calculate it that way, but it's essentially called the rise over the run. And with a linear function, it's going to be the same no matter where you are on this function. So this defines a lot for us. So m becomes really important, figuring out how we can calculate m. The other really important one is b. And the reason b is important is we need a point. And because this is Cartesian plane, you have your y and your x. What they tell you to look for is look for where the linear function intercepts the y-intercept. That's a really important part. Tactically, we could find any point, but this one gives us like a baseline. We're going to go to this line, we'll start here, and then we can kind of draw our function as long as we have our rise and our run. Okay? So what we can do, if what's neat about a linear function, is we can pick any 2 points. Any points at all. So, are you used to drawing or writing coordinates like this, where you have the x coordinate and then the y coordinate, and you write two the numeric values, right? Like
yeah.
Okay, so give me just any random numbers. We're going to talk about how we can solve
2
this.
and 4.
Pretty. So 2 and 4. And in order to get a linear function, you have to have 2 coordinates. So we'll call this coordinate number 1, okay? And we have to get coordinate number 2. So let's do another 2 numbers. Any other numbers you like?
3 and 6.
Perfect.
I'm just doing that.
Amazing. That's okay. Really simple. Okay, so we have these 2 things here. We can do a rough sketch. I know we have it kind of over here. We know that if we're on x, let's say our scale is by 1, so we'd be going like 1, 2, 3, 4, 5. This is the positive direction of x to the right, and this is the negative direction of x. So this would be like your -1, -2, -3. I know this is not a wonderful graph, but we'll go over to Desmos after and we'll confirm it, okay? Same thing with y. Anything going upwards is positive, so we're just going to go by scale of 1. And anything downwards is negative, okay? So if we go to write these points, the very first point is always going to be the x value. So we go over the number 2, okay? And then the y value is 4, and we go up to 4. It's kind of like a game of bingo, right? So here's approximately our point number 1. And our point number 2 is 3, and it's actually off the chart here, 6. Here's our point number 2. So we went over 3, and we went up 6, and same thing here. We went over 2 and up 4. So we just have to connect the dots here. So here's our linear function. Now, this is really, really messy. It's going to be very difficult to deal with stuff here. So what we're going to do is let's jump over to Desmos. We can write those 2 coordinates again. So we said 2, 4. Okay, so they've given us a point. There's 2, 4. Give it a label. We'll call it number 1. So we know that's our first coordinate. And then we said 3 and 6. We'll call this the second coordinate, okay? So we have our 2 points. And the linear equation is a line that goes right through those 2 points. So we have to figure out the equation of this line. So we have 2 points, that's great. We can get more and more and more. We just have to make sure they sit on this same line here. Okay? So important things to do in order to figure that out. We have to figure out the slope, because that's really the most important part, and a y-intercept. Now, if we look at these 2 coordinates, a y-intercept, there's something special about it every single time. A y-intercept always has an x value of 0. Always. Because it's across this vertical line here. So always the x value is 0. So if we go ahead and take a look at our 2 points, well, neither of these is the y-intercept. So we don't have it yet, but we can use this general equation here, y equals mx plus b, to figure it out. But what we do have are 2 coordinates, and 2 coordinates are excellent for calculating slope. There's an equation to slope. I'm not sure if you know it. They'll call it the rise over the run which is essentially the change in y. If you go into calculus after, they start talking like this, over the change in x. But how do we calculate that? We calculate it by the y2 minus y1. Have you ever seen this one? Divided by x2
Yeah.
minus x1? Yeah. And all that is taking the second coordinate, so that subscript. When they put the 2 below, it's not like a power. It's just talking about the second. They call it a subscript. So that's our second point. So x2, that's this one. Subtract x1, that's that coordinate. And y2, that would be this value. Subtract y1, that's that value there. Okay, so let's shrink this and actually work on that. So we're actually going to calculate our m. So we'll do that again. We said y2, y2 is 4. So I'll write it in red. y2 is the number 4. So we've just, actually I'll highlight it as we go through. There's our y2, okay? And we have to subtract by, whoops, gotta get that highlighter. There you go. We gotta subtract by our y1. We'll highlight that in blue. So this is gonna be our y1. Okay, and I'll write it in. That's the number 6. Oh, that worked out great. Over x2. We'll do that one in red also. So x2. Oh, I made a mistake with my numbers. But this is okay. We're going to talk about this. X2, I'm going to say is the number 2. And x1 is the number 3. So, here's a small error I made. I did call this coordinate 1 and this coordinate 2. And if you quickly notice, my y2 is the y value for my first coordinate. Okay, so that would technically be what's y1. But what's neat about this is it doesn't matter which coordinate you call number 1 or number 2. I could have said, you know what, this is going to be coordinate 2 and this is going to be coordinate 1. Doesn't matter, so we could flip-flop them. What we do have to make sure is that we're really consistent. That if the first y value I put here, the number, I have to make sure I put the x value that's a part of that coordinate. So 2 and 4, those are part of the same coordinate, so they're the first ones each time. And 6 and 3, they're the same coordinate, so they're the second ones each time. We can reverse this, and I'm going to do it at the exact same time so you see what I mean, because that may be a little confusing what I did, but I'm just going to reverse the two values. I'm going to say 6 subtract 4, and 3 subtract 2. So we have the two equations. All I've done is put one of them first in one scenario, and the other one first in the other, okay? And then we're going to calculate. So 4 subtract 6 is a negative value. We're going to get negative 2 on top. And 2 subtract 3, that's a negative value, negative 1. We'll continue on the bottom here. 6 subtract 4, that's 2. Over 3 subtract 2, that's 1. Okay. The absolute value, like the numerics, they look the exact same. 2 and 2, 1 and 1. The only thing is I have a negative and a negative. Are you familiar with multiplying and dividing? They call them integers, like positive and negative values.
Yeah.
So if we divide two negatives, do you know what that becomes? Yeah, it becomes a positive. Yeah, same as multiplying, okay? So technically, I can say that this number here is just the number 2, and this number, 2 divided by 1, is the number 2. So we got the exact same answer. Didn't matter which coordinate we put first, we just had to make sure we were consistent, and we didn't like mix up this y with this x. Like if I did that and that together, that would have messed everything up. Okay, so we've calculated slope. Now, I put it as a whole number, but it's actually best to do as a fraction because when we say rise over run, that means we have an amount to go up by and an amount to go over by. So any whole number, and a whole number is just, a number like this, the number 2, can be written as a fraction by just putting it over 1 because it doesn't change anything. So I'm going to do it again here. So our rise, is going to be the number 2, and our run is going to be the number 1. What we also just did is we also, in the equation, we calculated m. m is equal to 2 or 2 over 1. They're the exact same value, just one is written as a fraction, one is written as a whole number. So I'm going to bring our equation over here.
Okay, yeah, this is where it kind of starts to get lost.
Putting the value in. Okay, so what we're going to do is something called like substitution, okay? We still don't know what the b value is, so I'm still going to call it b. But our m, we just calculated for. In fact, m, we'll do it in blue. The m value is this. We just calculated. Notice I have an m here is equals, equals, equals. I kept going across. Here's our value. We got 2 over 1. So now what I can do is I'm going to replace just the m with that value there. So y is equal to, I'll write it in red, 2 over 1, okay? X, we're still times x. And b, I'll just write it in black here. We haven't changed anything. That's the only thing we changed was the 2 over 1. So we just substituted m for m. So once we calculated, we replaced that letter with this number here. Well, this is great. Well, that's what we need. We need a number here, and we also need a number here for b. Okay? But we're going to start with what we have.
Would it be better to keep it like that or 2? Like
2 is much easier to calculate with. If we're going to graph, 2 over 1 is much easier. So it depends on what we're attempting to do. Right now, we are hoping to get this equation, so you're right. It's better to change this just to the number 2. So I'm going to do that. I'm going to change this to y is equal to 2x plus b. We're coming along. That looks a little simpler to look at, okay? When we go to graphing, I'm going to tell you why it's easier. I'll show you when we go back to fractions, okay? The next thing we need to do is we do need to calculate this b value. That's important to us. So in order to calculate the b value, anytime we have an equation, you need to have only one unknown variable. If you have 2 equations, you can have 2 unknown variables to solve for them, okay? So right now, I don't know what y is, I don't know what x is, and I don't know what b is. So I don't have enough information, okay? We're trying to solve b. If I look back at the original stuff they gave me, I actually have an x and a y on this line. Either of those coordinates fall on this line. So I can do either of those. Okay, so what I'm going to do is we're going to move the equations to the next page. I'm going to plug these 2 in. So 2, 4, 3, 6. Okay, so let's do a new page here. Our equation said, let's do that in black to start. Y equals 2x plus b. Okay, and we had the coordinates of 2, 4, and 3, 6. Okay, and if you remember, these were both x values and those were both y values, these ones. So what I'm going to do now is I'm going to show you. I can plug either equation in and we're going to get the b value. It doesn't matter. So again, I'll call this scenario 1 and scenario 2. So scenario 1, I'm going to write y is equal to 2x plus b. And what we're going to do is I'm going to take this number 2, and it's an x value. I'm going to substitute it in for x. And I'm going to take this y, and I'm going to substitute it in for y. Okay? So we get 4 is going to replace y. So 4 is equal to 2. And 2 is going to replace x. So 2 times 2 plus b. Okay? Remember, the goal here is to get b by itself. We're trying to solve for b. So 2 times 2 is going to give us the value of 4. Okay. Did we do this right? Seems odd to me. Okay, we'll continue with it. I feel like the number's going to be off. Oh, no. Oh, that is going to be it. Great. We got to isolate for b. So if I have a value on this side, because it's a positive value, what I'm technically doing is like I'm subtracting by 4 on each side, or I'm adding -4 to each side. A lot of times they just refer to it as canceling out, like you bring it to the other side, it becomes the opposite. Either way, you're creating zeros. So think of it like these disappear, and then you're left with 4, subtract 4, because it was positive here, on the other side it becomes negative. Are you familiar with that?
Yeah.
Okay, it's called like balancing an equation. And we have b. And 4 subtract 4 is 0. So we have a b value of 0. So according to this, our equation is now y equals 2x. And we're going to replace b with the number 0. So plus 0. Apparently that's our equation. We'll write it in black as like a finality. The colors just kind of let us know what we changed. And because it's plus 0, we don't even have to write that. We can just write y equals 2x. But let's make sure we did this right. Let's do that scenario 2 I spoke of. We'll do the equation again. Y equals 2x plus b. And we're going to do the same stuff. I'm going to take the... Whoops, that's not what I wanted. I'm going to take the y value, and we're going to place y with it. And we're going to take that x value, and we're going to replace x with it. Okay? So let's see if this still works for us. Our y value is 6. Oops. Gotta change back. I always forget. There you go. So we replace y with the number, I didn't write 6, I wrote 4. With the number 6. Does that make sense?
Yeah.
Okay. And then we're going to take 2 and then times 3 is going to replace this x value here. So 2 times 3. Can you see the yellow?
Yeah.
Yeah? Okay. So we have our numbers. Okay, let's calculate and see. 2 times 3 is going to give us 6. We have 6 on this side plus b. Exact same thing we did on the other side. We're going to move this 6 over. So you get 6 subtract 6 is equal to b. And lo and behold, 6 minus 6 is 0. Our b value is 0 again. So our equation is y is equal to 2x plus 0. So great. Didn't matter which equation we plugged in, we got the exact same answer in the end. Okay, so that's really good to know too. When we're doing slope, we'll go back a page here quickly. When we're doing slope, it doesn't matter which coordinate we start with. Just make sure we're consistent and we'll calculate the exact same value every time. And when we're finding the b value, doesn't matter which coordinate we plug into the equation. As long as we're consistent, we plug in the coordinates from the same point, we'll end up with the same final equation. So we've got an equation. Oh, geez, I didn't realize. Y equals 2x plus b. Okay, get down here. Great. So when we go to graph this, y equals 2, and I don't even have to put plus 0 because when we add 0 to anything, it doesn't change. Yeah, so y equals 2x. That's great as in an equation form. If I'm giving a final answer in like algebraic form, they'll call it, this is great. That's my answer. But for my purposes, let's say graphing is going to be important. If graphing is going to be important, what we're going to do is we're going to take that slope and we're going to convert it to a fraction and we're going to write the 0 in. Okay, so this is the same equation, but I'm going to say y equals 2 over 1x plus 0. Okay? It's actually the exact same equation. 2 over 1 is divided by is 2. That works great. And when we add 0, we don't have to write in. But when we go to graph, this is going to make life really, really easy for us. So I'm going to shrink this just a bit. I'm lying. I'm not going to shrink it a bit. Okay, I don't know why that's doing that. There we go. Shouldn't do it that way, but that's fine. If I'm going to do a rough graph, so this is considered a sketch. I'm not being extremely accurate. I'm just kind of trying to get my coordinates here. 1, 2, 3, 4, 5. -1, -2. Okay, -1. And 1, 2, 3, 4. So I'm doing a rough sketch, and then on Desmos we'll do a really accurate one. The first thing I'm going to do is write out my coordinates, which we had done before. So we go over 2, up 4, and actually this has got to go higher, right? 5, 6, okay. So here's one coordinate. We'll call it coordinate number 1. The other coordinate here was 3 and 6, so we go over 3, 1, 2, 3, and up 6. Okay, and we have our equation. It goes like this. And our b value is 0. And remember what we said about the b value? It always has an x value of 0. So when we calculate b, what we're doing is actually finding the y value of the coordinate. So we found that the y coordinate was also 0. So that means it's going through the origin of the graph. I did a rough sketch. It looks like it goes through the origin of the graph. I mean, I wasn't using a ruler or anything, so we should check when we'll use the graphing software to check it. But that looks about right. And when we say a rise over a run, we're saying we go up 2 values. So from 4 to 6, we go up 2. So 1, 2. And then run is going in a positive direction 1. So we go over 1. So we go from 2 to 3 like that. And that worked out too. From our 2 coordinates, it looks like we went up 2, over 1. So we do the same thing. You go up 2 again, over 1. Yeah, that point looks like it lands on the line. What you can also do is, I don't know if you remember the very first page, we also found that -2 over -1. You can actually do that also. So what we do there is if I go down 2, 1, 1, 2, and I go to the left one, yeah, I'm still on the line. So those are working out great. So you can go either direction when you're using your slope. So it looks like, go down 2 again, over 1. No matter what we do, we're getting points along that same line. So that works out very, very well. So now what we need to do, going to Desmos, we got our two coordinates. Let's write our equation. Y is equal to, and we just said 2x was one of them. Hey, that worked out great. Cut right through both of them. But let's prove our other equations are also true. Y is equal to, we said we can go 2 over 1, right? That was one of the things we said. We write the value of x plus 0. Exact same thing, like I turn it off and on, it just covers that. And I can also say y is equal to, let's see if Desmos will let me do it, -2 divide -1. Yeah, they'll let me do it, great, I'm glad. X, and I'll just say, we can say plus 0 if we want, we know already that works. Great, that also works, right? So see, we had, I know they put the negative in front, but the idea is you have a negative on the 2 and a -1, exact same equation. So all of these are identical, and that's just how we graph it. So a lot of times they want us to graph by hand, so that's why I write either this purple equation here or this black equation are nicer for graphing. But algebraically, the green one is your best answer. Y equals 2x. Very simplified, very, very simple idea, okay? So let's pause it there.